Now the next thing that we need to understand is factorization. Factorization means simply breaking the given number as a product of prime numbers. So for example 6, I can write it as 2 into 3. The correct format is 2 to the power 1 and 3 to the power 1. So the power will represent the number of times a particular prime number is appearing in that number. So 12 is 4 into 3. But 4 into 3 is not the correct way of presentation. It is a good factorization, but the correct way of presentation of the final factorization is like this. 4 can be written as 2 square and 3 can be 3 to the power 1. Right? 120, it is 2 cube into 3 to the power 1 into 5 to the power 1. What it means is every number has a unique factorization. Always remember that. All the other things are different combinations. For example, 120 can be written as 1 into 120, 2 into 60, 3 into 4 into 10. You can write in hundreds of other combinations. All that is fine. But the correct factorization form is only this one. Or you can also say prime factorization. You can use prime factorization word. Right? But when I say simply factorize a given number, so simply factorization means complete factorization. Right? Complete prime factorization means all the parts should be clearly prime numbers. Others are just the presentations of products. So this is the meaning of factorization. Now why do we use factorization? It has various usages. The first thing is number of factors. So let's simply focus on number of factors now. If I want to find how many factors does 72 have, what is the first step? First step is 72 is equal to 8 into 9, that is 2 cube into 3 square. So the first step to find number of factors is factorize. Once you have factorized, now what is the sense of this? What is the meaning of this? The sense or the meaning of this is that for prime number 2, 72 is divisible by all the powers of 2 up to 2 to the power 3, right? Or I can also say that 2 raised to the 0, 2 raised to the power 1, 2 raised to the power 2 and 2 raised to the power 3. These are possible powers of 2 which are also factors of 72. The meaning of 3 square is 3 to the power 0, 3 to the power 1 and 3 to the power 2. These are those possible powers of 3 which are factors of 72. Now any combination here of these powers of 2, any combination here will give us a definite factor of 72. That is what it means, right? So any combination. Now combination means randomly 2 raised to 1 into 3 square type, 2 raised to 0 into 3 raised to 1, 2 raised to 3 into 3 raised to 2 and so on. Now how many such combinations can be created? So I'll write it like this. Number of factors is nothing but the number of combinations, number of all combinations of all available powers taking one by one. Combinations of available powers, right? Available powers of prime factors. For example, in this 72, the available powers of prime factors for 2, these are the 4 available powers. For 3, these are the 3 available powers. So the number of factors of 72, what will be the answer if that is the question? So how many combinations can you see? I can see very clearly out of these 4, any one. Out of these 3, any one. So 4 into 3 combinations. So 12 factors, right? There can be more than 2 prime factors also. For example, if I take 600. Now what is 600? First step, factorize. So 6 into 10 into 10. So 2 to the power 3 into 3 to the power 1 into 5 to the power 2. So what is the number of factors of 600? Can we check that? Number of factors will be equal to, for 2 cube, there are 4 possible powers. For 3 raised to 1, 3 raised to 0 and 3 raised to 1, 2 possible powers. For 5 raised to 2, 5 raised to 0, 5 raised to 1, 5 raised to 2. So 3 possible powers. 4 into 2 into 3, that is for 24 factors. Okay. So this is a very important aspect of this. Now let's see for perfect squares. Now number of factors for perfect squares. For a perfect square, let's say for example 144, which is 12 square. If you factorize, it is 2 to the power 4, 3 square. Can you see something? All the powers are even. Say for example 100, 100 is 10 square. So it is 2 square into 5 square. All the powers are even. I hope you can see that. Say 576. 576 is 24 square. 24 square is actually 2 to the power 6 into 3 squares. Right? So when you factorize any perfect square, you will always get all the powers even. 3600, that is 60 square, right? That is 2 to the power 4 into 3 square into 5 square. So for perfect squares, all the powers are even. So the number of available possibilities for the powers here will be odd. Check it. 2 raised to 4 means 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. So how many available powers of 2 are there? 5. Right? It will always be one more than the power, right? So for 3 also there will be 3 possibilities. For 5 there will be 3 possibilities. So the number of factors of 3600, I hope you can see it is going to be 5 into 3 into 3. That is 45. This 45 is what? It is odd number. Why is it odd? Because all of these numbers are odd. Okay. Why are these all odd? Because the powers are even. Right? In general, when we have to count the number of factors, if there is a number n, which is p1 to the power a, p2 to the power b, into p3 to the power c, and so on, the number of factors of n can be given as all the powers plus 1 and multiplication. So a plus 1 into b plus 1 into c plus 1 and so on. Right? So if all the powers a, b, c are even, a plus 1, b plus 1, c plus 1, they will always be odd. So their product will always be odd. So the number of factors of perfect square is always odd. So just keep this in mind. Okay. And vice versa. So for a non-perfect square, it's very clear that the number of factors will always be even, and vice versa. Number of factors is always even. Right? What does that mean? For example, if I say a number has 80 factors, that means clearly that the number is non-perfect square. Otherwise it is not possible. But if I say a number has 85 factors, there is no confusion. One thing that we know about that number, if it has 85 factors, it will be a perfect square. It has no other choice. Be very sure and clear about it. Now the next part, it says how many factors of 84,000 are divisible by a certain number, and certain other cases. Let's take one by one. Divisible by 10. We want all the factors of 84,000 which are divisible by 10. First, let's understand the question. What is 84,000 itself? If you factorize 84,000, it is equal to 4 into 10, 10, 10. So that is 2 to the power 5 into 3 to the power 1 into 5 to the power 3 into 7 to the power 1. So the total number of factors would be 6 into 2 into 4 into 2. Number of factors for this total. That will be 6 2s are 12, 4 2s are 8, 96 factors. So first let's understand the question. Out of these 96 factors, how many are divisible by 10? How do we do that? The simplest process, whenever you have to find the number of factors divisible by something, divide the given number by this number. So it is 84,000 divided by 10. You will get 8400. Or you could have taken the factorized form and divided. Now factorize 84,000 and find the number of factors of this. So 8400. If you factorize 8400, it is 2 to the power 4 into 3 to the power 1 into 5 to the power 2 into 7 to the power 1. Find the number of factors of this. The number of factors for this will be 5 into 2 into 3 into 2. 3 2s are 6 and 10, 60. Okay, so try to understand that out of 96 factors, 60 factors are divisible by 10. How many of these factors are divisible by 12? So 84,000 straight away divide by 12, and that becomes 2 to the power 3. Let me divide carefully. It is 7,000, right? So it is 2 to the power 3 into 5 to the power 3 into 7 to the power 1. So the number of factors of this will be equal to what? 3 plus 1, 4, 3 plus 1, 4, 1 plus 1, 2. So 4 4s are 16, 2s are 32. So out of these 96 factors, 32 factors are divisible by 12. How many are even? These are all positive numbers because factors are all positive numbers. So we can use divisible by 2. The meaning of even here will be divisible by 2. Right? So simply 84,000 divided by 2, you get 42,000. I'm assuming this is a standalone question in exam. It is 2 to the power 4 into 3 to the power 1 into 5 to the power 3 into 7 to the power 1. So the number of factors of this will be straight away 5 into 2 into 4 into 2, which is 80. So what does that mean? Out of total 96 factors, 80 factors are even. Okay. How many are odd? For odd, what will you do? Remove every 2. Remove 2 completely from the number. Then you will get odd. Remove 2 completely. Right? So what should I do? See, even kaise banega? The number will become even only if there is a 2. So if I remove 2, anything that I get is an odd number. So what was 84,000? Factorize 84,000 completely first of all. 2 to the power 5 into 3 to the power 1 into 5 to the power 3 into 7 to the power 1. Right? Now once you have factorized, then remove 2 completely. Find the number of factors for this second part, the remaining part. The number of factors of this will be 2 into 4 into 2. Right? So it was a 16. Try to understand that out of 96 factors, 16 factors are odd. You can actually check total of 80 and 16 is 96, which is very obvious. Now comes a very interesting situation, and that is something that you have to be really careful. How many factors of 84,000 are perfect squares? How do we go about it? First, let's understand the question. Out of 96 factors, how many are perfect square? This is what we want, right? I'll write here. Look at this closely. The correct factorized form of 84,000 is equal to 2 to the power 5 into 3 to the power 1 into 5 to the power 3 into 7 to the power 1. Listen to this very carefully. A perfect square can be formed. It can be formed only with the help of perfect square's prime factors. Can be formed only with perfect square prime factors. Now what does that mean? Don't worry, a prime number cannot be a perfect square. Okay, what does that mean? The power should be even. Perfect square, prime number, prime factor. So let's go back. I hope you remember the logic of available powers. 2 to the power 5 means what? It means 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4 and 2 to the power 5. If I want to find all factors, what did I do? I took 6. What does that mean? All possibilities. But if I want perfect squares, then I'll not take all of them. I'll take only the even powers. So for 2, I have 2 raised to 0, 2 raised to 2 and 2 raised to 4. I hope you can see that. Similarly for 3, all possibilities are 3 raised to 0 and 3 raised to 1. But we will take only 3 raised to 0. 5 raised to 3, it means 5 raised to 0, 5 raised to 1, 5 raised to 2, 5 raised to 3. But out of this even powers, because we need perfect square powers, perfect squares of the prime factors. Right? So out of these prime factors, what are the perfect squares? Only those which have even powers. What are the ones which have even powers? 5 raised to 0 and 5 raised to 2. Right? And for 7, we have only 7 raised to 0. Now their combinations from these prime factors, from these combinations, from whatever combinations we create from here will give us perfect squares. Count those possibilities. So the number of factors which are perfect squares can be counted from here like this. How many possibilities for 2? 3 possibilities. Right? How many possibilities for 3? 1 possibility. How many possibilities for 5? 2 possibilities. How many possibilities for 7? 1 possibility. So there are 6 factors. Try to understand, out of these 96 factors of 84,000, there are 6 factors which are perfect squares. Right? Similarly, for perfect cubes, so they can be formed only with, they can be formed only with a power equal to multiple of 3. So choose those powers of prime factors which are multiples of 3. The power should be a multiple of 3. So out of 2, powers of 2, can you see that 2 raised to 0 and 2 raised to 3? These are the only 2 possibilities. Out of the powers of 3, only 3 raised to 0 can be taken. Out of powers of 5, 5 raised to 0 and 5 raised to 3 can be taken. Out of the powers of 7, only 7 raised to 0 can be taken. This was 7 raised to 0 and 7 raised to 1. Okay. So how many combinations of these can be created? So for 2, there will be 2 possibilities. For 3, there will be 1 possibility. For 5, there will be 2 possibilities. For 7, there will be 1 possibility. So 4 factors. So there are 4 factors out of these 96 factors of 84,000 which are perfect cubes. Right? Now let's take a little more complicated situation. How many factors of n, which is 3 to the power 7, 5 to the power 10 and 7 to the power 5, are perfect squares, perfect cubes and perfect squares and cubes? Let's take one by one. To get a factor which is a perfect square, we need even powers of the prime factor. So for 3, what are the even powers? 3 raised to 0, 3 raised to 2, 3 raised to 4, 3 raised to 6, right? For 5, the perfect even powers are 5 raised to 0, 5 raised to 1, 5, not 1, 5 raised to 2, 5 raised to 4, 5 raised to 6, 5 raised to 8, 5 raised to 10. For 7, 7 raised to 0, 7 raised to 2, 7 raised to 4, right? So the number of factors of n which are perfect squares will be, for 3, there are how many possibilities? 1, 2, 3, 4 possibilities. And for 5, 1, 2, 3, 4, 5, 6. Now, I hope you can see that you don't have to write this counting. You can do it mentally also. And for 7, there are 3 possibilities. So 4, 6 are 24 into 3, 72. So out of total factors of n, 72 factors are perfect squares. Similarly, how many are perfect cubes? Now, to get a perfect cube, we need the powers which are multiples of 3. 0 can be taken a multiple of anything, okay? So multiples of 3. So for 3, we have 3 to the power 0, 3 to the power 3 and 3 to the power 6. For 5, we have 5 to the power 0, 5 to the power 3, 5 to the power 6 and 5 to the power 9. And for 7, we have 7 to the power 0, 7 to the power 3. That's it. So the number of combinations will be, or number of factors will be 3 into, for 5 we have 4 possibilities and for 7 we have 2 possibilities. So there are 24. So there are 24 factors of n which are perfect cubes. Now perfect square and cube. Now for a number to be perfect square and cube, what does that mean? It means that the power of each prime factor should be a multiple of both 2 and 3, right? Okay, and both 2 and 3 means it should be a multiple of 6. So check the power. So powers of 3 has 3 raised to 0 and 3 raised to 6, 2 possibilities. 5 raised to 0 and 5 raised to 6, 2 possibilities. And 7 raised to 0. All right. Okay. So how many combinations do we have? 2 into 2 into 1. Okay. All this can be done can be counted mentally also. So 4 factors. Now here you need to understand that these 4 factors are included in this 24 and these 4 factors are also included in this 72. Right? Now the next type of situation is, in how many ways a number can be presented as a product of 2 natural numbers. Now there are 2 cases here. For a non-perfect square, so for example 720. If it is a non-perfect square, it's a very simple situation. First find the number of factors. So 720 is 8 into 9 into 10 and that is 2 to the power 4, 3 square into 5 to the power 1. Okay. So first you find number of factors. Number of factors is equal to 5 into 3 into 2, which is 30 factors, right? Now, the question is, in how many ways it can be presented as a product of 2 natural numbers. In a way, we can say the number of product pairs, number of pairs that we want to find. Here, the number of pairs for a non-perfect square is straight away equal to, always without any confusion, half of number of factors. As simple as that. Okay? Simply half of number of factors. Fine. So in this case it is half of 30. Half of 30, that is equal to 15. Now here if you notice, there is no problem ever. 15 ways. Now why there is no problem? Because if the number is a non-perfect square, the number of factors will always be even, right? And it will always be very easy to divide by 2. But for a perfect square, the number of factors is odd. So here there is one more clarity that you need to have. Okay, number of factors is odd. Right? So what you should do is try to understand, is be very careful here. Let's take an example, 144. 144 is 12 square, 2 to the power 4 into 3 square. So the number of factors will be, number of factors is 5 into 3. That is 15 factors. 15 factors, right? So how do I find number of pairs, number of ways to present it as product of 2 numbers? How do we do that? Can I take 15 by 2? Now 15 by 2 is 7.5. Now this is a trouble. You can't have a number of pairs into fractions. So here you need to understand that there will be always 2 cases. Go back to the question and check. Does it say product of distinct natural numbers? Okay. Or does it say simply natural numbers? Right? So always go back to the question and check whether it says simply natural numbers or distinct natural numbers. If it is distinct natural numbers, then just remove the decimal part from here. Okay, so answer would be 7 pairs. Now what is the logic in this? See, why is it counting 7.5? Because if you see the possibilities, 1 into 144, 2 into 72, this way the last possibility will be 12 into 12. Before that it will be 9, 10, 12, 9 into 16 and so on. So this is the one that it is counting as half the pair, right? So if I have distinct natural numbers, I will not count this one, as simple as that. Others are 7 pairs, okay? But if it is simply saying natural numbers, then I'll take the next integer. 7.5 means I've just told you that this 12 into 12 is counted as a half pair. This is being counted as half pair, okay? So here you just need to make sure that if it is saying natural number, if there is no mention of distinct, then the answer would be the next value, that is 8 pairs. Or rather I should say that this count this half pair as a full pair. That's it. 7.5 is a symbolic number. It tells you what to take or what to go, whether you to go below this or above this. That will depend on distinct natural numbers and simply natural numbers, right? The next type of question is, in how many ways a number can be presented as a product of two co-prime numbers? Now what is the meaning of co-prime number? That you need to know beforehand. Co-prime numbers is not a standalone number. Okay, co-prime number is always more than one numbers, right? So if there are two numbers which do not have any common factor, if there are two numbers which do not have any common factor, they are called co-prime number, as simple as that. Okay, say for example 24 and 25. You see, none of them is a prime number, but there is no common factor between 24 and 25. So this is a co-prime pair, right? 5 and any other number which is not a multiple of 5, they are co-prime numbers. 1 and anything else, this is a pair of co-prime number. Okay, so I hope you can see that. You can also say that HCF of two numbers, if it is equal to 1, they are called co-prime numbers, as simple as that. Now in this case, how do we go about in this case? Now for this case, if I want to break the number as a product of co-prime pairs, co-prime numbers, so number of co-prime product pairs, this is equal to straight away 2 to the power n minus 1, where n is the number of prime factors. Try to understand that, number of prime factors. It doesn't matter what is the power of that prime factor, it is only the number of prime factor, and the number of pairs is straight away 2 to the power n minus 1. Try to see that n minus 1 whole thing is in power. So n is equal to 60. Let's do this one by one. 60 means what? 2 square into 3 to the power 1 into 5 to the power 1. So the power 2, 1, 1 does not matter. There are 3 prime factors, that's what matters. So n is equal to 3, right? That means the number of co-prime pairs will be 2 to the power 3 minus 1. So 2 square, that is 4 pairs. Okay, you can actually see what are those 4 pairs. You see from here, 1 into the entire 60, that is a co-prime pair. 2 square into, combine these two together, 15. This is an entire co-prime pair. Okay. 3 into 4 into 5, 20. That, take 3 out and these two together. Similarly, take 5 out and take everything else together. So these are 4 co-prime pairs. Right? 576. Achha, here it doesn't matter whether the number is perfect square or non-perfect square, because it depends only on the number of prime factors. So 576 is 24 square, that is 2 to the power 6 into 3 to the power 2. So only 2 prime factors. Power doesn't matter. So simply 2 to the power 2 minus 1, that is 2 to the power 1. So 2 pairs, as simple as that. Okay. What are those 2 pairs? You can see it is 1 into 576, everything. And 2 to the power 6 into 3 square. This itself is a co-prime pair. Any other pair will not be co-prime pair. Okay. 1680, factorize carefully. It is 16 into 105, right? So it is 2 to the power 4 into 3 to the power 1 into 5 to the power 1 into 7 to the power 1. So power doesn't matter. There are 4 prime factors, that's what matters. So 2 to the power 4 minus 1, that is 2 cube. So there are 8 pairs. Okay, I can show you those 8 pairs. It is 1 into the entire thing. Okay, then keep one prime number separate and all the others together. So 2 to the power 4, that is 16 into 105. Take 3 out and everything else together. So it will be 8 into 7, 560. Then take 5 out and everything else together, it will be 336. Then you take 7 out and everything else together, 80 into 3, 240. Right? So 1, 2, 3, 4, 5 pairs. Then there will be other pairs in which you can take 2 of them together and 2 of them together. So 16 into 3, that is 48 into 35. 16 into 5 is 80 into 21. 16 into 7 is 112 into 15. So 15 into 112. So these are those 8 pairs. Right? This breaking up the numbers will help you in many cases.